Okay, so hello everyone. Let's get started with today's class. So last class there was a problem with recording of the video, so we don't have the video of the last class. So officially I'll call this as lecture 9 and 10. So I'll just quickly, just for the sake of recording, I'll just quickly revise what we saw last time, and then we'll continue with today's class. Today we are going to see a lot of mathematical stuff, so be prepared for that. So, and also don't worry about writing down everything because we are anyway recording this, so you can always see it later. Actually, I should upload it and send you the link and all, which maybe I'll do it for the previous lectures today. So, in the last class, we were looking at Y bus or bus admittance. Okay, so just as a review, what I will do is I'll just take one question and then calculate the Y bus for that. Okay, so the question I've just, it's not any special question, any general question. So, just look at this question now. Suppose this network is given to you, and then the task for now is to find out the bus admittance matrix for this network. So we are only looking at the network part. What is the current injection at 1, at 2, at 3, 4, like that? The current injection is not given right now. We are only looking at the network part. So we construct the bus admittance matrix. That is all sufficient. So first step is what? Because these are all positive, that means they are reactances. So first step is you convert them into admittance. So 1 by J 0.5. So it will become minus J2. So I'll write it here, minus J2. Okay. Excuse me. What are you discussing? That discussion, that assuming the load is inductive and all, you could have done with the class instead of you yourself discussing. Okay, you can also consider load as capacitive. So let's say minus J 0.5. So this will be plus J2. So let me rewrite the symbol. By the way, it is not known that it is actually a load. Just some admittance is given to you. So you can also consider it as capacitive load. So what we are doing here is at 1 there is a capacitor, and then that capacitor we are incorporating into the Y bus, and then we are calculating the Y bus together. So if you have any very good doubts like this, instead of yourself discussing, you just ask so that others can also benefit. So this is now plus J2 officially. So what is this? Minus J5, because 1 by 0.2 is minus J5, and then this is minus J10, this is minus J4, and this is minus J10, and this is minus J10, and so on. Okay. So one more question is, can we consider this as capacitance? So we can consider this also as capacitance for mathematical purposes, for calculation and all, but then in general the line will have more of inductance than capacitance. So for power system it is always like this is reactance. All right. So what is the next step? Just by observation I can create the Y bus. Just by inspection or observation we can say. So the size of the Y bus will be 1, 2, 3, 4 buses are there. This reference bus is not counted. So I'll have 4 by 4 Y bus. So let me draw lines like this. So it helps if you draw the lines like this. So this is 1, 2, 3, 4. 1, 2, 3, 4. So, and then this is Y bus. So, how do we start? First, we start with off diagonal elements. So, the elements which are not on the diagonal. So, look at 1. 1 is connected to 3. So, between 1 and 3, there is a J5, minus J5, but then you have to reverse the sign, so it becomes plus J5. So, this process we have seen in the previous lecture. This is all with respect to applying Kirchhoff's current law here. Okay. So, this will become plus J5 at 1, 3. Okay. So, here, so there is no connection between 1 and 2, so it is 0, and then this is J5. So, this is between 1 and 3. Then there is no connection between 1 and 4, so this is also 0. I can copy that here because it is symmetrical, the row gets copied into the column. Now let us talk about Y11. So Y11, there is an extra term plus J2 here. So, but then I have to add all these and then reverse the sign. So this is minus J5 and then plus J2 because of this one. So this will be equal to minus J3. So this is the 1, 1 term. Okay. So now look at the second row. Again, we are interested in only the off diagonal elements. So is there any element between 2 and 3? Yes, there is minus J10. So its sign will reverse. It will become plus J10. So this is between 2 and 3. It is J10. And then between 2 and 4, there is also same thing, J10. So J10. So I'll copy here J10, J10. Now the diagonal element. So there is no connection between 2 and the reference. So I can just simply add the entire row and then make the sign reverse. So it is minus J20. So why we are doing this? What is the procedure? It's just simple application of Kirchhoff's current law. So maybe one example we'll see after completing this, so that it will be a complete review. So now we come to the third one. So 3, 4, there is minus J4, it becomes plus J4. So here J4, and then there is no connection between 3 and ground. So I just simply add all these things. 5 plus 10, 15 plus 4, 19. So this will be minus J19, and then this will be same J4. And then I add all these things. This is J14, so it becomes minus J14. And then this minus J10 also will get added because it is this one. So it will be minus J24. So this is the Y bus matrix for the system. So how is it, what kind of variables does it relate? So it relates like this. So it is I1, I2, I3, I4. These currents are related to V1, V2, or is it, so this is V1, V2, V3, V4, and then these are related to I1, I2, I3 and I4. So this is the Y into V. So this is Y bus into V equal to I. Okay, this is just Ohm's law applied for the entire network. So shall we just look at only the second I2 part? So what, just not I2, we'll take 4 because there are more terms. So if there is some current being injected here, I4, which is unknown, which was there before also, I just drawed it now just for writing the equation. So incoming current is I4. So outgoing current is what? This one and this one. So this current will be equal to this plus this plus this. So what is the current on this branch? That will be V4 minus V2 into J10 minus J10. So this is admittance into voltage difference. So this is the current on this branch. What is the current on this branch? That is V4 minus V3 into minus J4. That is current on this branch. And what is the current on this branch? Simply V4 minus 0 into minus J10. Okay. So this all three currents, current on this branch and this branch, the addition will be equal to I4. So all of this I have to add, it will be I4. So if you notice how it will come, if I rewrite it in this form, I will write V1, V2, V3, V4. Then for the case of So I4 I'll just put in the middle. So there is no connection between this one. So this first, that is the V1. There is no V1 in this. We have 2, 3, 4 only. So therefore this term is 0. So 0 into V1. So what is multiplying with V2? So there is this one, only this one. So this will be minus and minus. It will become plus. That's why it is like this. So it will be J10. So 0 into V1, J10 into V2. And then what happens to the V3 part? So this will be plus J4. So V3 is there. And then V4 has both of this with minus sign and then it also. So therefore it will be 10 plus 4 plus 10, 24 with a minus sign. So it will be minus 24. So if you see, this row is just like same as this row. So what we are doing by building the Y bus is actually writing KCL at each node, and then these two are like equivalent. So I hope this is what is a quick review of the lecture 9. What we have done at the end of the lecture 9, I was able to relate into this equation, Y bus equal to V into I. Okay. So the reverse part of that is like we have Y bus equal to V into I. I can write, sorry, Y bus into V equal to I. So now I can write V equal to Y bus inverse into I. So this one is V equal to Z bus into I. So today we'll just, in lecture 10, we'll talk about this Z bus, how to build a Z bus. So one way you already see. So from here, if I want to build a Z bus, I will simply take this matrix and then invert it. So how do you invert a 4 by 4 matrix? So if I give you 4 by 4 matrix and ask you to find inverse, so you will have to use some kind of computer, some kind of this one. You can maybe do it hand calculation, but I don't know how exactly to do it. Certainly for a larger system, suppose if the system size is 100 by 100 or 500 by 500, that much big matrix, obviously you cannot invert it right away. You have to use some kind of computer program and all. That is also, it is found that it is little difficult to invert large matrices. So another way of finding this Z bus is for building the Z bus into step-by-step process. So for building the Y bus, I can do it by observation, that is there. But then for building the Z bus, directly like this observation and then writing out, that is not possible. So it is little more difficult. So that difficult part we will try to see today. So actually, I was thinking that I give you the final steps how to do it, and then this is how you build. But then I thought I will also, instead of just blindly asking you to follow the procedure and then build the Z bus, I thought maybe once you should also look at the derivation or the steps why to do it. And then it is very interesting case where how you are using basic mathematics thing in power systems. So that is one example. Okay, so what I'll do is the lecture 9 part I will stop here, and then we'll start talking about bus impedance matrix in today's lecture. So is this fine? I hope I have not made any mistake anywhere. So we'll see. Okay, I'll just erase it now. Okay, so now I'll just directly go to this, and then so before we start talking about bus impedance matrix, I want to talk about some mathematical concept which will be useful. Okay, so some maths. So that is Crons reduction. So we'll quickly look at this Crons reduction, because later on this Crons reduction I am going to apply for in our power system. Okay. So what is Crons reduction? So it is not a very difficult or very high level kind of concept. It is just manipulation. of equations. Okay, suppose the problem, I'm just giving you the problem part. Suppose the problem is given to you like this. I'll say B1, B2, Bn. So some constants, some numbers like this. This is multiplying with some big matrix A, and then this one is x1, x2, xn. Like this I have. So you can immediately see there are n equations here. First equation, second equation, third equation. There are n equations. Now assume that this is unknown and this is known and this is unknown. So actually even if this is known, then you can solve it and then you can find out, but then assume that this is also unknown. Now, so I have n equations, but then 2n unknowns and all, so we cannot immediately solve it. Now after this, what this cron he has done is that now let's take if additional information. If Bn equal to 0, how to eliminate xn. So this is a problem that cron is trying to solve. So if I one term, if I make this one 0, so there is this last equation I have, this is 0. So in that case, how I can eliminate xn and then make this a smaller. So now the a size is n cross n. So if I eliminate one equation, xn also variable, if I eliminate, then it will become n minus 1 by n minus 1. So that step is the Crons reduction. How to do that? So you can immediately see if I put 0 here, so I'll get one equation relating xn with all other things. So I'll take xn on the left side and put everything on the right side, and then I will back substitute that in all the other equations, and then I can eliminate the xn. So if I ask you to do it on your own, you will do it yourself. So just because this person invented it first, his name we are getting. So this you also can do. So let's look how we can do it. So I will rewrite this like this. So I'll rewrite this like this: B1 to Bn minus 1. So this is there, and the last one is 0. So this is given to us. In that case, what happens? So I will partition this A. So I'll call it A dash, and then I'll take the last row and last column. So I'll just take the last row, last column, and then this remaining part I'll call it A dash. Okay, looks like A1. Let's say A dash. So this one I'll just rewrite the name. So this one AN row. This piece I'm calling it the nth row of A, not row, column. AN column. So is that okay? And then this is AN row. And then this is ANN. So this is just a single number. This is a row from here to here, and this is a column from here to here. I'm just doing nothing different. Just this one I am just rewriting like this. And then here I have x1 to xn minus 1 and then xn. So this is still unknown, this is known, and this is unknown, but this one is known. So 0. So I can now write it like this. I'll just only focus on the last row. Okay. So what is 0 equal to? 0 equal to AN row multiplied by x1 to xn minus 1, okay, plus ANN xn. So is there any problem in this? I just took the last row and then this into this and plus this into this. So this is what? N minus 1 rows and 1 column. This is 1 column and n minus 1 rows. No. 1 into n minus 1 into 1. So this entire will be one element. So and then it will be multiplied. So from this I can find out what is xn. That was our original idea. What is xn? So I'll say xn is equal to. So I'll take this whole term on the other side and then bring this one this side. So minus 1 by ANN into the same thing. AN row into this one. X1 into xn minus 1. So from this step follows directly. Okay. Next, what we have to do? Now, what I'll do is I'll write the above equations. From here to here, I'll write it. Okay. So I want to use this space only, or maybe here I'll write it. So B1 to Bn minus 1. So I am only writing the above this part. Okay. So that is what A dash. Okay. A dash multiplied by this x1 to xn minus 1, okay, and then plus ann into xn, sorry, an column into xn, ann will not come, so like this. So this is n minus 1 by n minus 1, this is n minus 1 by 1, and then this is n minus 1 by 1, and then this is 1 by 1. So I'm just giving you the size of matrix. So only from this one I am writing like this. So now what I will do is, this we already calculated what is xn. So this thing I can directly substitute there, and then I have the final solution. So what I will do is, I will write b1 to bn minus 1 is equal to a dash. Okay. Now, if you notice, this x1 to xn minus 1 is same here also, x1 to xn minus 1. So I can take that common. Okay. So I'll take that common. So that one is here, x1 to xn minus 1. We'll do an example problem also on this. So now what is there in between? So I'll simply put minus 1 by ann. So that is this one. And then first I'll put column, then I'll put the row. That will be the multiplication. So actually this should always come first, because here it is on the first. So I can bring this one on the other side, but not the row one. So an row. That's all. So if I do this calculation, so now if I mark this as one new matrix, so what is the size of this matrix that I just drawn? It is n minus 1 cross n minus 1, and then this is n minus 1 cross 1, and then this is n minus 1 cross 1. So therefore we have eliminated one equation. So I reduce the size of n by n into n minus 1 by n minus 1. So this is the invention, or this is the mathematical whatever proof of Crons reduction. So it is, if you look at an example problem, you will actually find it is very, very basic, easy, and to understand. Any question? This one? See, just notice here, this into this matrix, whereas here also this matrix is common, x1 to xn, because I want to substitute this one in the place of xn. So because xn is, so this is, let's call it equation 1, substitute in equation 2. This is equation 2, I don't know, it is substitute 1 in 2. So just this one I am substituting there. Okay. So I'll keep the final solution there itself. We'll just do one problem. Okay, one sample example. Then it will be very, very obvious for you. Okay. So okay, the example is like this. So let's say B1, B2, B3 is equal to some numbers. Okay, so some 3, 7, 1, 2, 5, 3, and then 8, 2, 1, something like this. Some matrix. Okay. So this is x1, x2, x3. Okay. So this is given to you. So here it is 3 by 3. Now I want to eliminate one of the equations. So it is very clear now. So so now if B3 equal to 0, then eliminate x3. So this is the question. Okay. So what I will do, just notice here now, you can stop writing. So if B3 equal to 0, eliminate X3. Okay. So I will mark this one as one matrix, this one as one matrix, this one as one matrix, and this is my ANN. Okay. And then I'll just use that formula. So what is A dash? 3, 7, 2, 5. This is my A dash. Okay, that A dash. The 2 by 2 part. Yeah, but the way we have written, it is more, the formula that we have written is that we are. So suppose if I want to eliminate x2, if b2 is 0, just reorder this and then rewrite it and then you can do the last one. Okay, if b3 is 0, how do you eliminate x2? So for that, this formula does not work. You have to derive your own formula. How will you do it? Like, because the way we are writing it, this formula is only for eliminating the same rows. Yeah. Yeah. So we can do that. So the idea is that if you reverse the columns, then these variables will get reversed. So reverse the columns and then you can do that and then you can eliminate x2. Very good observation. Yeah. So I was thinking whether to cover all these things or not, whether people will be able to follow or not, but then at least 1 or 2 people are asking some intelligent questions. So at least I think I'll go ahead with this. So if again you are feeling that this is too complicated, then then you should compare with some of the people and then try to catch up. Okay, minus 1 by 1. Okay, that ANN is 1. Then column into row. So my column is 1, 3, and then my row is 8, 2. That's all. So this is my new matrix. So what is it? So 3, 7, 2, 5 minus, so 1 into 8 is 8, 1 into 2 is 2, and then 3 into 8 is 24, 3 into 2 is 6. So this will be equal to, so I'll write it here. So 3 minus 8 minus 5, 7 minus 2, 5, 2 minus 24, minus 22, and then 5 minus 6, minus 1. So this will be x1, x2, and this will be b1, b2. And then we eliminated the x3, okay, using this Crons reduction. Okay. So let's do a quick verification. So how will you verify whether this formula is working or not? Just we'll do our old fashioned way. So just simply write it like this, verification. So I'll just write it like this. I'll just expand the last one. So I'll expand the last one, 0 equal to 8x1 plus 2x2 plus x3. So from this I will write x3 equal to minus 8x1 minus 2x2. Okay, is this okay? I taken the last equation and then converted x3 left side and the remaining thing on the right side. Now substitute this in the first equation and second equation. So what is the first equation? b1 equal to 3 into x1 plus 7 into x2 plus 1 into x3. First equation. Now in the place of x3, put this one, x1, x2. So that will be 3 into x1 plus 7 into x2. And then what is x3? Minus 8x1 minus 2x2. So this is 1 is there. So 3 minus 8 is minus 5 x1. 7 minus 2 is plus 5 x2. So this is b1. So if you notice, this equation and this equation is same. Minus 5x1, 5x2 is the same thing. Again verify for second equation. So b2 equal to 2x1 plus 5x2 plus 3x3. Now in the place of x3, I'll substitute this one. So it will be 2x1 plus 5x2 minus 3 plus 3 into minus 8x1 minus 2x2. So this will be 2x1 plus 5x I will not write all this. So 2 minus 8 into 3, 24 minus 24, so it is minus 22 x1, and then 5, so 3 into minus 2 is minus 6, so 5, that is minus x2. So again you see B2 is this one, so it is matching with this, minus 22 into x1, minus 1 into x2. So basically what, writing like this, what is the thing is, we are saving the chalk piece for writing x1, x2, x1, x2 everywhere. So using matrices we can solve it faster. So, and then blindly if I use this kind of formula, I can eliminate one of the equations. So is that okay? And this works for larger sizes also. So, and then if you want to eliminate any other variable, as one of the students said, we can exchange the rows and then we can do all that. So you can try all that. So, so far, so shall I write down that quick formula here? So A equal to A dash minus 1 by ANN, A column, nth column, and then A nth row. So I'm just putting it as one formula which we'll use it later. So this is Crons reduction. The size of this one is n minus 1, whereas the size of the regular old A matrix was n by n. So we just reduced. Okay, what does this all have to do with power systems? So far what we saw is just mathematical this thing. So now we'll apply it to example of power system. Okay, as I said before, there is no like observation kind of thing. You inspect or observe and then build the Y bus. But for building the Z bus, the procedure is little longer. So that longer procedure, you have to go element by element, one by one. You have to construct the Z bus. So there are 4 cases as we noted before. So I'll write on that one. So let's call it case 1. Case 1 is add ZB to new bus, let's call the new bus as Q and reference. I don't know, I should use this much space. Okay, so this is the case 1. What you are doing is, because I am saying step by step, assume that already you have a, like this, already I have a Z bus. It's already there, n cross n. So this is relating to what? I1 to IN is equal to V1 to Vn. So already this is there with you. Now I want to add one more extra element. Okay, the element I want to add is like that, case 1. So that means this is the Z bus. Let's denote it as a network. So this is Z bus. It's a network. So there is a reference bus. Okay, and then I want to add, let's call this one as Q. This Q I want to add like this. I want to put a ZB and then I want to add it like this. Okay, this is the first case. And then now my new bus will become like this. So this is my overall new bus. So the size of this will become n plus 1 by n plus 1. Okay, so this is one case. So what is case 2? So in between I will write down what we have to do there. Okay, case 2 is like this: add ZB to okay. So I'll just say between. Add ZB between new bus Q and reference bus. So add ZB between new bus Q and old bus K. So there is already one old bus K. To that I am adding the new bus. Okay. So as a figure, how it will? I'll redraw these figures once again. I'm just erasing it here. So instead of adding this one to the reference, so there is already one bus K here, and then I want to add it like this. Okay, this is the second case. Okay, so this case is second case. We will see what to do in the case of that one, second case. Okay. Okay, to save space, I will not write down the third case and fourth case. We will come to that. First, we will worry about these two. Okay. Now let's go back to the second case. Sorry, the first case. Okay, this voltage is 0 here, and this is the old Z bus as it is. Now the current injection is IQ, and the voltage here is VQ. Okay, so this bus is Q. So now notice here, I want to derive the formula for this. Okay, so there's a bus Q, there's an impedance, and then the current I'm injecting. So in fact, these two are unknown, but then these two are like what we are thinking as the notation. IQ is the current injected, VQ is the voltage of this bus with reference to 0. So we can actually write down the Ohm's law here. So what is VQ? Is nothing but IQ into ZB. ZB into IQ. So this is just VQ directly. And the interesting thing is, this current is not affecting the regular whatever this thing. So if I write like this, V1 to Vn, Z bus, I1 to In, so these equations are not even touched, because this branch is separate and then directly it is going to the reference. Okay. So what I will do is, these are n equations, and then this one equation I will attach to the end of this. So how to attach this one to the end of this? Simply I'll put VQ under this, I'll just put VQ and then add one element here. Okay. And then I'll put IQ here. So what should be the row and column that should be added here? So the old Z bus is like this. So what I'll do is, I'll put 0, 0, 0, 0 like this, and then put 0, 0, 0, 0 like this, and then here I'll say ZB. So what happens now? Look at the last equation. 0 into I1, 0 into I2, 0 into IN. So this is anyway 0. And then this into this. So the same thing. So the last equation is like that. And then is IQ affecting any other V1 to Vn? It is not affecting, because V1 is the regular expression comes 0 into IQ, 0 into IQ like that, it comes here. So this, because of these zeros, this IQ is not affecting the old voltages, but IQ is affecting only the new voltages. Okay. So I hope this shortcut explanation is okay. So what is the solution for case 1? Suppose ZB is added between a new bus and this one, simply Z new equal to Z old and then 0, 0 and then ZB. That's all. So this is how I will update the Z bus. I take the old one, put zeros and in the row and column, and then just put the ZB here. So in this case, the size increases by 1. Okay. So this is case 1. All right. Now we'll once again look at one example, and then we'll compare the old method of Y bus inverting and then the new method of Z bus building, and then we'll try to compare the answers and then match the answers and all that. So right now I'm just giving the procedure. Now let us talk about case 2. So here it is slightly difficult or slightly tricky. Maybe I'll not use this much space. All right. Between Q and 0. Okay, so let me draw the diagram for this here. Okay, the diagram is like this. So this is bus Q, this is bus K, and this is Z base, or ZB, not Z base. Here I am injecting current of IQ. Okay, but you should also notice that the old bus already it has one IK injected in it. At the bus K, IK current was already injecting, but now I am additionally sending the new current. So this current will be IK plus IQ, which is entering into the network. We will see how it comes later. So, and the voltage here is VQ and the voltage here is VK. Okay. So this is the diagram for the case 2. Okay. So just we'll write the voltages equation. So simply if you see VQ minus VK is what? This voltage minus this voltage is the voltage drop here. That is nothing but IQ into ZB. So, or I'll write ZB into IQ. Okay. So, this is just a simple Ohm's law. We will use it later. So, let's call this equation 1. Okay, just we'll use it later. Okay. Now notice here. Okay, so V1 Vn is equal to Z bus. This is the old one, old Z bus. I1. There will be one row which correspond to IK, and then this is IN. So this is the old voltages, old Z bus, old currents before adding this branch. Now, the moment I add this branch, what happens? So we just notice that there is one extra current adding here, IQ, in for that kth element, and then let's call this as new. This is new. And I am not writing here, there is one more row I should add what is VQ. That I will add below that. But so because of this IQ, V1 will change, V2 will change, everything will change because of this new current IQ. Okay. That is after adding that. So I'll just rewrite it once again. So I'll write it like this. Z bus I1 to IN plus ZK column multiplied by IB. So what I have done is that just split this into two parts. So notice here what happens. This row, whenever suppose I calculate what is V1, the element which is in the kth column. So this is the kth column, for example. The element in the kth column will get multiplied by IQ. So when I calculate V2, the second element in the kth column will get multiplied by IQ, apart from the old terms. So similarly like that. So what happens is the entire kth column is getting multiplied by IQ. So that's why I am writing ZK column multiplied by, sorry, this is IQ. Okay. So you see how this step comes from this above step. So this is the old same thing, everything is same as previous. Just that instead of putting plus IQ here, I write IQ outside and then only take that column here. Alright. So again, this is not that much complicated for you, I feel. Now what I'll do is, I'll do one more magic now. So just take Z bus and then I'll attach one column here, okay, to this. The column that I am attaching is ZK call. So here I will put I1 to IN and then put IK below, IQ. Okay. So again you see this step to this step is again same thing. We are just playing with matrices. So what happens? The first row multiplied by 1 to n and then one more term will multiply by IQ. And then it's anyway addition. So like that. So the size of this is n cross n. and the size of is n rows and one column. So now because that one column I added extra, so this size will increase by one column. Is that okay? So this is the main what you call the key or the core or the important steps. You know how to come from here to here, just splitting this, and how to come from here to here, just putting IQ below here, extending the length of this, and then putting that as one column. All right. So we achieved so far up till here. Now, see what is Vk? I can look at this. Suppose this is, I look at the kth row of this, then I will know what is Vk. Kth row. So I'll write it here. Vk is equal to the kth row of Z bus. So how will I notate it? Zk row. Okay. The kth row of Z bus, I'm from this I'm writing into I1 to In, I1 to In. Okay, plus, so the kth element of kth column. So that will be ZKK. This is a simple number multiplied by IQ. Is that okay? This is Vk. From here, instead of the entire all voltages, I am only interested in one voltage Vk. So kth row multiplied by this plus ZKK into IQ. Okay, this is Vk. Now when I look here, Vq minus Vk is this. So if this Vk, if I take the other side, I'll get what is Vq. So I'll simply write Vq is nothing but Vk plus this term Zb into IQ. Alright, so I'll jump again. So if I want to write it Vq, so this minus Vk went that side, become plus Vk, this itself, plus this term. So what I'll do is I'll take IQ common and then I'll write Zb here. Is that okay? So this, I take the same row and then this one and then Zk plus Zb into IQ. Okay. Next I'll do one more small magic kind of thing. What I'll do is, this is Zk row. To that row I will attach this one, Zkk plus Zb. Okay. And then I will call this I1 to In and then IQ below. Okay, I don't know, the writing may not be clear here, but you can see the step. What I am doing is, this IQ I am attaching below, this will become one last element in this row. Okay, now what I can do, now this row, this VQ row I can attach to this one. So it's all like operation we are doing. So what I can do now is, here I have V1 to Vn. So here I am attaching VQ, the same thing. So what I should attach? The row and then this term. So I'll just put a dashed line. I'll put a ZK row and then ZKK plus ZB. That's all. So this will give me the new voltages and all. So how we are addressing this case is like this. The kth row and this one. So if this is the kth row and kth column, this term is ZKK. So where is the ZKK coming? The ZK coming here. So from this step, okay, I jumped that step. So yes. Yes. Plus this term ZKK into IQ and then this ZB. So I took IQ common, so it is like this. This one? So this ZKK comes into picture because of this one. The kth element of this one multiplied by IQ. You lost track? I think we have time. So I can do one more thing. I can do an action replay. What? Where? Inside this. Here. Here. So this ZKK is multiplying between with these two. Okay. ZKK is actually the Thevenin's impedance of node K with respect to the reference and all. That we'll see that in the end. Okay. So you want me to just do one more replay for of all this? No or yes? I'll do a. It will be a fast. It's not actually a slow replay, but I can do it very fastly. Or I'll just review it here itself. So you see, this was the old diagram. There's a bus K. I added one new bus Q. Added this ZB. Inserted IQ current. That IQ current will flow in this, and then we'll add to this. So because of this, I am writing like this. So this is the voltages V1 to V1, new voltages. Here I just add one extra Q. This one I split into two parts. So only the column will come out. From this, I can rearrange it. I can put IQ below, and then this one I can attach as a column. So that's what we did here. And then how did I get the last one? So simply use this one. So VQ is, I'll write it here, VQ is VK plus ZB into IQ. So from that I got this, VK will be, this term is VK. So up to here, this is VK. So VK is kth row into this one into ZKK into IQ, and then this term is already there. So and so on. So let me write the final what to do here. Final step. So in the case this one, so what is Z new? Simply take the Z old, copy the ZK column here, copy the ZK row here, and then take the ZKK term, add to the new ZB, and this will be my new Z bus. This is how I'll update the Z bus for this case 2. Take the old one as it is, then copy the kth column, copy the kth row, and then take the KK term, add it to the ZB. This is my new. So here the size also increases by 1. Alright. So shall we go to case 3 now? So between, I'll write Q and K. This was like this. So let's look at case 3 now. Case 3 is add ZB between Q and K, both are old. I think that is case 4. So case 3 is like this, between old K and reference. So there is no Q here. So there is an old bus K that is added to the reference. Okay. What? Let me draw the diagram, it will become clear. So the diagram is like this. This is a Z bus and this is the reference bus. So what I am doing is, I am taking a bus K which is already inside. It's an old bus. Okay. And that used to have a current of IK. To that I am adding one ZB and then I am connecting back to the ground. So I am just adding like this. Okay. So how to address this? What to do in this case? K is already an old bus and then like this. So this is the bus K. So it has a voltage of Vk and then this current is, let's call it IB. So what is the IB? So before that, see again one trick we are playing now here. Imagine that this was open circuited. Okay. Imagine that this was open circuited. Now what is the thing? So there is a new bus Q connecting to K. This is exactly like case 2. So if I just open circuit this, I am connecting VQ, ZB, and then this is exactly like case 2. Okay. So what will you do? You just repeat this entire process. Alright. Now if I close this, what happens? That particular VQ will become equal to 0. Okay. So this is where we use Crons reduction now. So if I write this again once again, so just copy from case 2. From case 2, I will get like this, V1 to Vn, in between there is Vk. So I'll get Vq here. The same thing I'll copy. I'll get Z old and then Zk column, Zk row, Zkk plus Zb, and then this is x1 I1 to Ik, and then this is Iq, or we are using IB or whatever. So if this was open, then this is VQ, new node is created, and this is the step. Okay. Now what I am doing is I'll just close this, and then this is 0. Therefore this term is 0. Okay. So if you make this term 0 and then I ask you to eliminate IQ, you can eliminate IQ using the Crons reduction. Okay. And this is the Crons reduction we already noted before. So what I will do now? How do I solve this one? I'll simply write it here. So Z new equal to Z old. Okay. So this one A equal to A dash. So this is A and this is A dash. Okay. Minus of, what is the term here? So this term. So Zk K plus Zb. So this term will come there, and then the last column and the last row. Okay. So Zk column and then Zk row. Okay. So this is the update I'll do that will take care of case 3. So you are following it again, the idea. So what I am doing is, I am just using this one, Crons reduction, I am just updating it that way. Now there is only one last final case, which is case 4. Case 4 of this one, add ZB between old K and old J. So there are two buses K and J. Between those two buses, I am adding a ZB. Okay. What happens now? So again, I'll draw the diagram for that. So this is the reference. So there are two buses. This is K. This is J. Okay. So earlier this current was Ik and this current was Ij. Now I added one branch between two old buses. So this is ZB, and let's say this current is IB like this from here to here. So down current IB. Okay. This is Ij. So this is the diagram for that. So what will this current be? Ik minus IB, and this current will be Ij plus IB. Alright. So if this branch was not there, then same thing, but then because of adding this branch, these changes have come. And I also know what is this one, Vk minus Vj is equal to Ib into Zb. As simple as that. So the voltage, this voltage difference is nothing but this I current into impedance. Okay. I'll rewrite it like this: 0 equal to minus Vk plus Vj plus IBZB. So just I am taking these two on the other side. So just remember this part from coming from the diagram. All right. Now we'll again start doing some magic. Okay. So see here, V1 to Vn. This is my Z old, and this is I1 to In. Inside that there is Ik, and then there is Ij also somewhere. Okay. So this was the old case. So now what about the new case? In the new case, I'm adding, for K I'm subtracting minus Ib, and for J I'm adding plus Ib. Is that okay? So because of addition of this new branch, I'm just getting these two terms extra. Okay. So what happens in the next step? This will be equal to, that is V1 to Vn will be equal to what? Z old I1 to In now whatever is the kth column, that kth column will multiply by minus Ib, and whatever is the jth column, that jth column will be multiplied by plus Ib. So it is nothing but j column minus k column into Ib. So I'll say plus z j column minus g k column into Ib. So from this step you will get this step. So I take the jth column and then subtract from the j column, will subtract the kth column and then multiply it with Ib. Okay. You already know what is my next step. I'll simply put the Ib below here and then attach, this is just a one column. I'll attach this column to the old bus. Alright, so just to save space, I'll write it above. So from this step, I'll go above, so I'll get V1 to Vn equal to Z old. I'll attach one column here, that is Z. See, I'll just use again a simplified Z j minus k column. That means what? Just the jth column minus kth column, just minus, and then this is I1 to In, and then one extra current Ib. Okay. Now, what is Vk? What is Vj? Okay. So I'll write it here. So from, just look at this old one. The Vk will be the kth row multiplied by this I1 to In, and then the kth terms of this one. Okay, so I'll write it down here. Zk row multiplied by I1 to In. This is this term plus. So here I'll just write the individual elements. Okay, Zjk, sorry, Kj, kth row, jth column minus Z kth row, kth column into Ib. So this is my Vk. Okay. Again, I'm sorry to squeeze everything here. So this is Z j row and then this is same thing, and then here it will be ZJJ minus ZJK, jth row kth column multiplied by IB. Okay. So now look here, 0 equal to minus Vk minus plus Vj, this one. So this 0 I will put here. So this 0 I am putting there, and then I will add this row under that. So what is the row that I am adding here? See, the negative sign is for k. So this k will have the negative sign, j will have the positive sign. So same thing. J minus k row, that means jth row minus kth row, that will take care of this term. And then what about this term? So this is all minus sign. So this is slightly bigger. So I'll write it here. So this denominator, this one is positive, jj plus zkk plus I am adding this term also, jb, ib into jb plus jb plus gb minus 2 into zjk. So if I add this term, that will get multiplied by IB, and then this is taking care of the last equation. Okay. So now again, when you look at this, my interest, I don't want to find out what is IB and all. There is a 0. I want to eliminate the last row and last column. So then I again use the Crons reduction to eliminate that. Okay. So for that, what I should do, I will write the final here, update step. So here Z new equal to Z old minus 1 divided by this whole thing. Okay, so that is Z JJ plus Z KK plus ZB minus 2 ZJK. Okay, and then multiplied by J minus K column, J plus J minus K row. So if I do this update, then I taken care of case 4. Okay, so this is my 4 cases. I think with these 4 cases, we have completed all possible cases of building a Z bus. So now I can take an example problem. I can quickly work out the example problem as it is. Okay. So we still have maybe 20 more minutes. I think 10 minutes is sufficient to work out. Actually, it is very easy. It looks complicated, but when you look at the example problem, it becomes easy. All right. Before I go ahead, you people, somebody should have a calculator where you can invert a 3 by 3 matrix. Does somebody have a calculator where you can invert a 3 by 3 matrix? I know that some of the calculators you can define a 3 by 3 matrix, and then, but I don't know whether you are able to invert it or not. So you might be having a doubt, will it work this much, this thing, will it come correctly or not? But then it will come correctly, don't worry. So I'll just remove this. We can't touch any of this. Otherwise, we'll do one thing. I want to clear the board actually. So I hope you have written this in one place, at least some of you. Okay, so later on I'll ask what is this formula, then you should be able to tell me, so that I'll just substitute it and then solve it. Alright? So you are written or you are written? You are showing each other. Don't worry, I have written on my paper also. So now what I'll do is, we'll take one example problem and then we'll calculate two methods. One method is the Y bus. So the problem is like this. So it's a small problem. So this is bus number 1, bus number 2, bus number 3. Okay. Now what I want to do is, first I will calculate the Y bus, then I will invert it, and then I will get the Z bus. So that is one method. Next is, I will try to construct the Z bus based on the whole process that I discussed some time back. So then we will compare both the results, whether we are getting the same answer or not. Okay, so that is the thing. So if I want to construct the Y bus, what is the first step? I'll convert everything into admittances. So I'll get something like this. So this is J5 minus J5, and then this is minus J10, and this is minus J0.5, and this is minus J1. So this is 1, 2, 3. Okay. Now what is my Y bus? I'll write it here itself. What is Y bus? Between 1 and 2 there is minus J5, so it will become J5. Between 1 and 3 there is no direct connection, so it is 0. Therefore here it will be, but then 1 and 0 there is minus J1, so it will be minus J6. This one I will copy here. So look at the second one, 2 to 1 already taken care, 2 to 3, J10. So that J10 will come here, this will be J15 with a minus. And then 3 to 0, this is minus J, so it is minus J10.5. Okay, so this is my Y bus right away. So this one you should be able to do it very fast. Now how to invert the Y bus? So what I'll do is, I'll take J out. So if you take J out, I'll get Y bus equal to J into minus 6, 5, 0, 5, 0, minus 15, 10, 10 and minus 10.5. Okay. So the inverse of this is like, first I have to invert J separately and invert this one. So this will become 1 by J, and then the inversion of this. So what is the inverted value of this one? Here is where you require a calculator. So this matrix, minus 6, 5, 0, 5, minus 15, 10, 0, 10, minus 10.5. If you invert it, what will be the matrix? Maybe I'll write the answer here. This is Can someone quickly invert that matrix and tell me? Okay, so you got minus 0.7 for this. So one thing here, this 1 by j will become minus j, and this minus minus will cancel and j will go inside. Okay, so it will be j 0.7. More decimals, just 2 decimals you can tell. J 0.69. I'll not even write 0. J 0.69. Okay. The next term J 0.63. J 0.60. So I'll just copy the same row and column here. Okay. What about this one? 2 element? J 0.76. J 0.72. So here also it will be 0.72 because it is same. And then this one, last one is J 0.78. So I got some matrix. This is by inverting. So I use a calculator, invert the y bus, and then I got this solution. Okay. That was the first method. So let's do the other method. So again, notice here it is not that difficult. So building jet bus. So first step is add. See, this is my reference, and then I am adding J1. I am getting the node 1. Okay. So this is my first step I am adding. Reference plus J1, this one. So add J1 to reference. Okay. So what is the step? What you should do? So you might have written it in your notes. So you take the old one and then put zeros, and then put zeros like this, and then put the ZB here. But then since we don't have any old bus, so I am directly, there's nothing, no zeros to put, directly I'll put the ZB. Okay. So my Z bus is nothing but J1. That's all. This is my first step. So the it is always like suggested that you start with the reference to some bus, because otherwise the other cases is difficult to do. So it is customary to always start with a bus where you 0 to 1 you start like that. Okay. So now what will you do next? So first step is over. So this is like I'll write it. This was case 1. Okay. Now next what I will do? Add. So this is added. Now I'll add J 0.2. Okay. J 0.2 between 1 and 2. Okay. So 2 is a new bus. 1 is an old bus. So I am adding a impedance between the old bus and a new bus. So it is like case 2. Okay. So what we do in case 2? Very simple. Just take the Z bus. This is the old Z bus. Copy the first row. Copy the first column. Copy the first row. And then here I'll take J, this one, plus J 0.2. So this will become J 1.2. Okay. That's all. So your case 2 second step is over. Okay. So what I have done, copied the first column, copied the first row, and then here I am taking the term Z KK plus ZB. So ZKK is J1 and ZB is 1.2. Okay. Again, add. So adding J 0.1 between 2 and 3. So add J 0.1 between 2 and 3. Okay. So this is also case 2. Because 2 is the old bus, 3 is the new bus, I am adding one branch between the old bus and the new bus. So what I should do? Simply take the Z bus, take the same copy as it is, J1, 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 J1.2. Then copy the second column, so J1, J1.2. Copy the second row, J1, J1.2. And then here what you will do? This one 2 plus 0.1. So it will be J 1.3. That's all. So this is my So if the problem was given without this, this is the answer. Okay. So next, let's look at the next step. Now add. So J2 between 3 and reference. So between the reference bus and bus 3, I am adding a J2. Okay, so this is what case 3. Okay, case 3. So what we should do in case 3? So let me write down what to do in case 3. Z new equal to Z old minus 1 by Z kk plus ZB into ZK column into ZK row. Okay, this is what we noted down in the notes before. Okay, so very simple. What you do now is just take the old Z. So first let me calculate this term. Okay, so what is ZK column? The third column, because we are now adding the third column. So this one. So I'll take J1, J1.2, J1.3. This is my third column. And what is my third row? Same thing. So multiplied by J1, J1.2, J1.3. Okay. So this term is this term is this. Okay. So first let me calculate that. So J into J is minus 1. So 1 into 1, 1, 1 into 1.2, 1.2, 1 into 1. So I'll put a minus overall outside because J into J is minus 1. 1 into 1.3, 1.3. 1.2 into 1, 1.2. 1.2 into 1.2, 1.44. 1.2 into 1.3, 1.56. Okay, this I mugged. So 1.3 into 1 is 1.3. 1.3 into 1.2 is 1.56. 1.3 into 1.3 is 1.69, 13 square. So there is a minus outside. Okay, so this whole thing is this one. So there is also another minus here, and then 1 by ZKK plus ZB. So what is ZKK? J1.3, that is the 3 term. And what is ZB? That is my J2. That's what I am adding, this one. Alright. So J2 plus J1.3 is J3.3. Okay. So this is in the denominator. So minus 1 by J 3.3 is in the denominator. This one is multiplying with this. So minus minus will become plus, and then this is multiplying. Okay. But then since J is in the denominator, if it goes up, it becomes minus. That's a different story. So what I'll do is, because it's a constant, I'll write it this side, 1 by 3.3, and then I'll put minus J here. Alright, so this is 1 by 3.3 multiplies with everybody in this. And what was my old this one? I'll take J common out of this old, this one, J common. So I have 1, 1, 1, 1, 1.2, 1.3, and then 1, 1.2, 1.3. So just this is what is our updated bus. Okay. So again I depend on you. So let's try one term only one term to begin with. Okay. See, what is 1 divided by 3.3 and then subtract it from 1? How much is that? I'll take the first term. So 1 divided by 3.3, you can try it in your calculator, and then subtract it from 1. It will be around 0.69. Can someone try that? See, 1 divided by 3.3, subtract it from 1. So we are getting this term. Okay. So let's try the next one. 1.2 divided by 3.3 and then subtract it from 1. So can I put equal to sign here? So 1.2 divided by 3.3 and then subtract it from 1. So someone can try this term, someone can try this term, someone can, different terms, you try it. Because all of them you can do. So suppose if you want to do this one, 1.3 divided by 3.3 and then subtract it from 1, are you getting 0.60? So just verify each term, are you getting all of these? Anybody trying out any other terms? What? All are correct? So what we are doing is just this method is inverting of Y bus. This method is slowly building the Y bus. For very large systems, this method is easy. For small systems, this method is easy. So if you are writing a big software code for making a very large usually this is the method followed. Find out which case it is and then update your Z bus like that. Yes. Because 2 is a new bus, it is case 2. But if 2 was already an old bus, now if I add one more, suppose if I add one more like this, 1 is old, 3 is old, and then if I add it, then it becomes case 4. But at the time, in the ordering in which we are adding, it is new. So I think we'll stop here. So you can come and then collect your this one. So this is 11 batch and this is 10 batch. I just separated only that much. So you can just pick up one of your this thing.